meaning if it's an inverse, let's say that this is the regular function. This is the point 5, comma 1, right? And if it's an inverse, you can just interchange the x's and the y's, and that should be on the inverse function. So 1, comma 5 is right here. So that's one graphical definition of inverses. If you interchange x and y's, they will be inverses. Okay? And of course, we can do that with each of these points. So since we interchange the x and y's on all these points, and they end up to be all these points, we know that they're inverses. And by doing that, since we interchange the x and the y's, it looks like a mirror image over the line x equals y. Meaning if we say, let's let this x equal y, let's let this y equal to x, we end up flipping over the line y equals x. That's cool. So that is the graphical representation. So I'm going to give you some a paper with 6 graphs for your homework. You're going to be given a function. You're going to have to graph that. They're all going to be linear equations, not going to be triangles. It's going to be like y equals mx plus b. And then you're going to find its inverse and graph that, and you're going to see it's a mirror image. So 2 ways, just based upon the graph, is it an inverse? Number 1, is it a mirror image over this diagonal line? And 2, if you pick any point, can you just interchange x and y and have it be on the other inverse function? So 2 ways. All right. So again, we're not going to be doing this with triangles and stuff and shapes. We're going to do it with actual functions. Okay, so if I give you a function, this is the first part of your homework, can you find the inverse and graph them both and see visually that they're inverses as well? Okay. So step 1, how do you find the inverse? If I give you a function, how do you find the inverse? Okay. Here are the steps right here. Basically, you're going to exchange x and y. Flip x and y, and then solve for y. And you'll have the inverse. Okay? Now, we are starting off with f of x, and we're going to end up with this f inverse of x, or inverse of x, f. We don't say f to the negative 1. We pronounce this the inverse of f of x. Okay, so we'll just start off by saying, okay, let's make the f of x y instead. Okay, so that's step 1. Step 2, again, just like the graph, we're going to interchange or switch x and y. We'll make this x equals y minus 3 all over 5. And then, since I can't graph when it's x equals, I don't know how to graph x equals, I'm going to solve for y. A little bit of Algebra 1 skills here to know. Well, if it's y minus 3 divided by 5, how do you solve for y? What's the first thing you have to do? Get rid of the 5 by?
Multiplying by 5 over 5.
Yeah, multiplying by 5. So undo dividing by 5 by multiplying by 5.
Yes.
All the same old rules that you know. And then, of course, lastly, how do you get y by itself? X. So not too bad. So we know we have 5x plus 3 equals y. And again, we don't want to leave it as y. We want function notation. So we're going to, as soon as we have at the end y, we're going to replace that with f, the inverse of f of x. Instead, inverse. So we have to graph both of these. That means slope-intercept form. What's the y-intercept or the starting point? Yeah, we're going to start at 3 on the y-axis. And then how are we going to move? Up 5 and right 1. So remember, if there's not a fraction, you put it over 1. So up 5, right 1, starting from 0, 3. So lastly, graph them both. And again, we should see that before anything else, we already know if we do it correctly, should be a mirror image across this diagonal, y equals x. Because what are we doing? We're exchanging x and y, interchanging x and y. So it should be a mirror image over x equals y, the line x equals y. All right, so let's graph. As we said before, this is all slope-intercept, right? Y equals mx plus b, right? So we begin here, so we're going to begin at 3 on the y-axis. Then we're going to move up 5, right 1. So up 5 will be right here, right 1. Of course, we can also go down 5 and up 1. Same thing. Use the straight edge. You've got to use a straight edge on these. There we go. So we expect, just preliminary, we expect, well, if my line right here goes through, let's say, 1, 8, right? I expect my other one to go through 8, 1. So it's going to go in this direction. Okay, so let's go ahead and graph this. It's not in the slope-intercept form, so do all the normal steps so it's slope-intercept form, which would be, on this case, would be divide that by 5, divide that by 5, distributive property. Remember, it's like a 1 right here. So that's 1/5 x minus 3/5. All right. Go ahead and graph that. So begin B at -3/5. Now, where's -3/5 on the y-axis? Find -3/5 on the y-axis. Where is that? Need to change it to a decimal. Calculator, if that helps. Where is that? Where is it? Find it. Find it. What'd you get? 0.6? Like right here? No. Hey, 0.6. Yeah, right about there. Like almost half. 0.5 is a half, so 0.6, still more than half. We're only estimating by on the graph. And then we have to move up 1 and right 5. Up 1, right 5. So up 1, and right 5. And up 1, hey, and right 5. Right about there. So, seems to put on a 1, right 5 right here. Right around there. That's right around there. And go ahead and plot that. So, yeah, does that look like a mirror image over the diagonal line? Yeah. If you interchange some numbers, 1, 8, 8, 1, and it's only estimation since this is fractions, that's fine. Okay. So yeah, looks pretty good. Looks pretty good. So mostly you can see if you're really strong in the algebra one, this is a piece of cake. If you remember the slope-intercept form, rise over 1, oh, I got to put this over 1. You know, I'm not afraid. I can find 3/5 on the number line. That was from the 5th grade standards. Find this fraction on the number line. You can find it. You know, and then it doesn't phase you that, well, how do I go up 1 from -3/5? That'd be -3/5 plus 1 is 2/5. But really just estimating. So if you're really comfortable with your slope line intercept and your fraction work, it'll be pretty straightforward. If you're a little scary, if like you saw this -3/5, you're like, oh, what do I do? Okay. Like you said, just make it a decimal. Okay, -0.6. Okay, I can do that. And go from there. If you're really, really cautious, you can say, okay, -0.6 plus 1 is 0.4. So we have to go up to 0.4 and write 5. Okay. But just remember, it's just an estimation when we have fractions. We're not doing exact. use all the tools you know and to help you out. Alright, so let's have you guys practice a little bit. You guys practice. Try this out. Find the inverse, following all the steps. Just prove yourself you can get that. So, next part, the second set of problems for tomorrow night will actually involve exactly what you did on your work last night. We'll have to find f of g of x and g of f of x. Only this time, you're looking for a specific answer for each of them. If you do both of them, just like you did in last night's homework, and both of them come out to just x, then you know without graphing that they're inverses. That's kind of nice, because we always start off, let's graph it and see how it looks. We do it with parabolas, we do it with polynomials, and we say, well, graphing is kind of time consuming. Let's have another way of doing it without graphing. So this is that same, following that same line of thinking. It's great if we can graph, but a little bit faster if we don't have to. And of course, like you saw, if we have a y-intercept of negative 3/5, the graph isn't 100% accurate. Well, this is always accurate. So just have to go through. You can do like a 2-column. That's what I recommend. They're going to give you 2 functions, and you just have to do the same thing you did yesterday. Find f of g of x and g of f of x, and just verify that both of them equal x. Now, if one of them doesn't equal x, you really don't have to continue on the problem. So on this particular one, we have f of g of x. That means you take g of x, this whole thing, 1/3 x plus 4. You plug it in right here. So we have 3 times 1/3 x plus 4 minus 3. And you're trying to see, does it equal x or not? If it equals x, we continue on and we check this one. If it doesn't equal x, then no, they're not inverses. Because we need them both to equal x in order to be inverses. So we get 3 times 1/3 is 1, so we get 1x. 3 times 4 is, and then minus 3 is x plus 9. So conclusion? Not inverses, or no. So, yeah, that's it. We're just using the same technique we learned yesterday, but now we're actually applying it to something that's useful. So without graphing, we know if we did go through and actually graph these, you wouldn't be able to switch x and y coordinates. It wouldn't be a mirror image over the diagonal. And again, it doesn't matter what this comes out to. We just need one of these not to be x and that's not inverses. Yeah.
So if we get the first one of x, we need to do the other one.
Yeah. So if this one comes out to x, then yes, you have to verify the second one. Brings us right here. So one more example. This one, they will come out. So find f of g of x, which means take g, plug that in for x. So we get 3/4 times 4/3 x plus 8 with minus 6. Distribute 3/4 times 4/3, 1x. 3/4 of 8, 6, and minus 6. So yes, it comes out to x. So far so good, but you're not done. So here's the case where you have to verify. Well, let's see, make sure it's true to the other one. So we want to take f of x this time and plug it into g. So we have 4/3 x. That's 3/4 x minus 6 plus 8. And then of course 4/3 times 3/4 is 1. 4/3 times negative 6 is negative 8. And then come. So yes, they are inverses. Another way of denoting this would be, so g of x is the inverse of f. Okay. Means that these are inverses. This is f of x, this is the inverse of f. Okay. G of x is equal to the inverse of f. And that's part 2. So not too bad. A little bit of graphing. My guess is the slope y-intercept for a few of you will be a little rusty. Ask questions like always. Check the back of the book when you get home on the odds. Make sure you're getting the right answers. Don't just do the whole thing and come tomorrow and find out I just did all those wrong. Yeah. Check as you go. We got lots of time, almost a half hour today, so you might be able to finish all this in class if you just stick to working and don't waste time.
Can you do it back?
So what?
The last